Hello class, so in today's lecture what we are going to do is to get introduced to the concepts of the assemblies. Any product, unless it is something extremely simple, like I don't know, a paper clipper or maybe a hair comb, those are like single parts, but most of the time you are making an assembly. Assembly can be made by the two or more parts. And on the first day of this class, we talked about the workflow of making the models in parametric CAD and in SolidWorks as an example, where we first go through like the concept sketch, then we make the parts, and then we make the assembly. Finally, we assemble the parts. When we have all of the parts ready, and we make the assembly of the ready-made parts, that's called the bottom-up approach. And the equivalent will be like I have a bucket of parts that goes into my engine, let's say, and I'm assembling an engine. So I take the base part, what will usually be the block of the engine, and then I put whatever, like the pistons, put the rings on the pistons, put the piston into the sleeves and so on. So the piston will itself not be a single part. Piston will be an assembly because it has rings and it has the pin connecting rod and probably some retaining rings and so on. So same process like if you build something out of the basic parts, we follow in a computer with a CAD, and if we have all parts ready to assemble, that's called bottom-up assembly, and that's what we will do today. However, many times when we design the new things, like a new product, we do not have all the parts ready. But we can start by designing, for example, overall shape of a mouse or overall shape of the car, and then carving out from that master model piece, carving out kind of building the new parts. That approach is called the top-down approach or top-down assembly. Most of the time we combine the two. So because you will have some parts ready, especially like standard hardware, parts that you buy, but then you will have some parts that you will need to design to fit the form and function of the project. So today we are going to start with introduction to the bottom-up assembly, and we are first going to do the basic exercise 5.2 at page 299. And for that exercise, we are going to start at drawings in a millimeter. And I'm going to make that little L-shaped bracket, which is 80 by 80 by 80, and it has like the L of 40 by 40. So I will make this L-shaped bracket by making a single rectangle, which I will call to be a square actually of 80 by 80 millimeters. And to make a square, all what I need to do is to say that those are equal in length. And I'm going to make another square, which will be just to the half. And I'm going to specify actually the distance here to be at the 40. And the other one, and the other distance to be also 40, because that's the midpoint, it's already specified. Okay, so I'm ready to extrude this block, this contour, the L-shaped contour. I'm ready to extrude it for an 80 millimeters. So to extrude, I will choose the area that I want to extrude, blind, add 80. And that will be like my block, kind of something like a simple, not Lego block, but kind of like some block that you can build many other stuff. And I will call this piece, let's see, how is this piece called here, block test. Now, I can start making assembly using my block test. To start an assembly, you go File and make assembly from part. And that's the block test that I will use. So you click on a part which you want to use, which is open, and then click OK. and we brought that part now into the assembly view. Into the assembly workbench or assembly view, you can all see here now on a parametric tree we have individual parts. And then we have a mates. Mates will define how individual parts are arranged in a space relative to each other. First part that you drop in will by default have an F prefix, what means that the part is fixed. You see, we cannot move it. If we want to make it to be able to move it around, we will right click on the part and click on a float. I'm not going to do that. So we brought in this part. Now if I right click on it and let's try to float it, left click on a float, now I can move the part around. You see, when the part is in a float, when there is no F here, that means I can move the part around. I can move the part arbitrarily. I can rotate the part also by pressing down on the middle button of the mouse. Or I can move the part with a move component, and I can move it in an organized way. So I can move it in a either as a physical dynamics or collision detection, or can do something, or I can use even a smart mates, which we will do later. Okay, so now we are going to insert, we are going to cancel this move. I'm going to insert another block. I'm going to make this block to be back fixed. So I will go Control Z, Control C, Control C. Going to insert that component again, block test. Going to change my assemblies to millimeters. And I'm going to create my first assembly. I'm going to bring another part exactly like this inside my assembly, and I'm going to mate it like that. I want to have those two parts glued to each other on a side surface. So I will click on the insert component and click on my block test and just bring it anywhere in the space. Now, obviously that part that I just bring in can move as much as I want. So how can I put it that to be glued with the corresponding surface aligned? To do that, you will use a command which is, you will use the mates. And the simple mate that we will do now is the coincidence mate. And the coincidence mate is exactly a glue. So if I click on a coincident mate, I can choose like, let's say, this surface, the face of the new part, and I want that surface to be glued to this surface. And click OK. As you can see, now these two surfaces are glued, but that's the only mate I have, so still does not position part entirely. How can I position this part to be something exactly like this? Well, I need to use more coincident mates. Coincident can work on the face to a face, edge to an edge, or point to point. So think if you are gluing these two blocks, what you will do. You will probably want to align like these two faces. So let's see if I say coincident. Look what happened. Now they are aligned. Those two faces are aligned. Now I can only move it in a one direction. And now to completely glue it, what else I will need to do? I will need to align two fronts or backs, doesn't matter, but in that direction, something that will prevent motion in the opposite direction. So if I click on the plate here, and you see here is the face 4 of that block 1, and then I click on another face here, and I click that those two are coincidental, and I will click maybe on this one and on this one to be a coincidental, and look what happened. Now I can't move it anywhere, it is completely glued, and here we have something that is called a fully defined assembly. The mark for a fully defined assembly, what means that nothing can move, that everything is defined here. So, if we go to a page 308, the second assembly now, we want to rearrange them. We want this to look like that. So, if I open the directory of the mates, look at this. If I click on the mates, I can delete all of my mates. Click delete. Now I can freely move this. All what I have to do is to mate these surfaces, the front two surfaces. However, it is not oriented as I want it to be oriented. What I will need to do to reorient it, I will need to click on the alignment button. There is an align and anti-align. If I click on anti-align button, it will do the opposite glue. So like, let's see what it can flip over. Look what it did. It flipped it exactly how I wanted it. Click OK. Now, those two are aligned. Actually, let's see. Yeah, those two are now aligned. Not really. Let's see what is the mate that we just created. Okay. Those two are aligned. Now we need to align it more. We will need to align side surface with this one. So I can click on a mate. And then we need to align the bottom with the bottom. And look what I get. I got the fully defined assembly with these 12 blocks, which looks like this. With the same 3 mates, however, differently aligned. Now, we can make them to be like kind of an interlocked. So let's do that. Again, what I will do, I will delete all of my mates. And I'm going to interlock. So to make them in a position to understand what I want, I can also use the rotate under the move component. I can use the rotate component. I can move it something like to approximate position how I would like it. So this is how I would like them to be interlocked. Now, who will tell me what will be my mate here? Some surface. Which mate? How about this top surface on the fixed block with the bottom surface on this block? Click OK. Green button. Now, how about this side surface with the side surface? Click OK. And finally, the front surface with the front surface. Click OK. And look, it is a fully defined, and the 2 blocks. The 2 blocks are fully interlocked. That's like the assembly on a 309. So we made from the 2 simple parts 3 different assemblies. We can continue experimenting with any different possible combination of those 2 L-shaped blocks and practice the mates command. The first mate that we are practicing here is called the coincident mate. So there are many other mates which we will explore today and in the next class. However, let's first get familiar with the simplest one, which just let us to glue the 2 surfaces.